We're going to have a look at an idea of using the quadratic function to solve a problem. And this is a really good use of math problem. So I'm going to be bringing in really quite fast here some of the information that we had last time, some of the algebra that we used last time. So y equals x minus a, x minus b in brackets. That would give us kind of like the conventional quadratic, but then if we wanted an inverted one, we could use x minus a, b minus x. That would give us a negative gradient. Then also the completing the square way of looking at it, where p is the maximum height or the maximum depth of our quadratic, and q is the position of that height or depth. And so we used these last lesson, we set these up, we've explored them, we've drawn a few different ones, and we're ready to use them now in the context of a problem. And so what we're going to do is we're going to look at spanning a bridge, or spanning a gap using a bridge, I should say. So there's the gap. It's very big, and it's going to go for 50 meters. So it's a 50-meter gap, and then we're going to have a bridge that goes between the two, and then it's got that lovely quadratic or parabolic, that lovely curve there that we can use a quadratic to model. And what we're looking at then is also the height of above the water. There's some water, as you can see. And I want the height. It's 50 meters across, and I'd like the height. Can I have the height? Lovely. So how much is it going to be? So we're going to have 18 meters of height here, okay? So now what we've got then, 50 span across, 80 meters of height. So we're going to model this and make it look like a graph. And, you know, a really clever idea is to think of our y-axis as being right in the middle of that bridge. So the first clue I've got, what have I said? Start with, oh, seems to have given up. What have I done? There. So we're starting with that graph, and there we are. We're using the y-axis in the middle, and so that splits our 50. Minus 25 one side, 25 the other. And so we can now use the two brackets, and we've got x minus 25 and 25 minus x. Is that right? Is that right? I think that's going to come back to bite me. It really is. Let's have a look. So what do? Let's put the height in now. And the maximum height will occur when x equals 0. That's the great thing, because we're using this y-axis as the central part, the symmetry in there. I see something's going wrong there. Have you seen it? Can you see what's going wrong? We've done something. Yeah, it's going to come. Go on, try and work it out then. So we have 0 minus 25, and then 25 minus 0. So that will give us minus 25 times 25, which of course is minus 625, which is not above 0. Something's gone wrong. What is it in the way in which we did it? We didn't use the formula as we wrote it down, and that's where it's gone wrong. I'm trying to solve it, trying to work it out now. I'm having a real problem. Can you see? Any second now. Putting a plus in. No, that's not going to work. That's just going to make it go like a conventional quadratic, and go down. So we're still going to end up with minus 625. We need to do something about the 25. See if you can get it. That's it. Go back and then put minus 25. There we go. Now that is going to give us a height of 625. That's far too much. We needed 18 meters. Too high, much too high. So what are we going to do? Now we've used the two brackets method. Perhaps if we went with completing the square. If we use the completing the square method, we can control the height. We used the two brackets method because that sort of established the gap of 50 meters. But by doing this by using 18 meters, perhaps that will help us do it. So we put the 18 in, and we know that the 18 occurs right in the middle, which of course is when x equals 0. Yeah? Put the 0 in. So now we're going to have y equals 18 minus x squared. No, look, there's a completing the square now there. We're going to have the square root of 18, which is just not going to be good. It's going to be 4 and a bit. There's no way. And if you put 25 in, which I'm doing there, you can see we've got minus 607 meters. either side. That's just ridiculous. All right then, let's go back to our original way of looking at it. That was working for us. We've got the span, and we're pinned down. If we can pin the curve down at the x-axis at the minus 25 and 25, then maybe we can do something to the curve. Maybe we can bring the curve down to 18. Now we can't subtract anything because that will move all of it down. So we're going to divide. We're going to divide by 625. That won't affect where it crosses the x-axis. And then we multiply up by 18. Well, you're going to have a go with these, I think.